Righto, if you haven't already done so, in your books, write a summary of the pre-operational stage, including definitions of egocentrism, animism, transformation, centration, and reversibility. So pause this video now and get stuck into that really awesome task. Okay, welcome back. Next, we've got the concrete operational stage. So this is from about 7 to 12 years old. This stage is characterised by children thinking about what they know and what they can experience through their senses. What is concrete? So this is about kids saying, okay, I can see this, I see how it works, I understand. A key achievement in this stage is understanding a theory called conservation. Not conservation as in trees and environment, but rather mental conservation. Conservation refers to the idea that an object does not change its weight, mass, volume, or area when the object changes its appearance or shape. So, for example, when the child realises that pouring from one glass to another doesn't change the amount of liquid, it might just change the shape that the liquid's being held in, then they've achieved what we call conservation of volume. So they understand that pouring from glass A, which is short and fat, into glass B, which is long and skinny, doesn't change the amount of water we've got. It just changes the shape because of the receptacle we're holding the water in. There are several types of conservation. There's volume, which is the sort of classic Piagetian experiment that we've seen, like the glass task. But there's also conservation of mass. So an example of that would be, let's say you give a kid 2 balls of plasticine, they're the same size, but what you've done is you've rolled one into a long, skinny sausage. The kid that understands conservation of mass understands it's still the same amount of plasticine. Okay, so I start off with, and I'll draw this one for you again, I start off with 2 balls of plasticine that are the same size. Terrible drawing. And this one here, I roll it out, so it's no longer a ball, it's a nice skinny blob of plasticine. So the child that understands conservation of mass realises that these are the same amount of plasticine. If the child doesn't understand conservation of mass and you ask them which one would they like to play with, this one or this one, they might say, this one, it looks way bigger, it's got more. Or if you just gave them this one, they might say, hang on, I want this one, it's got more. Whereas a child that does understand conservation of mass realises it's the same amount, it's just that this one got rolled out. There's also conservation of length. So, for example, let's say you've got yourself 2 pencils, pencil number 1 and pencil number 2. And let's imagine they're exactly the same length, except I'm a terrible drawer. So we'll just erase a smidgen off the end there. Now that you can see what's happening with this pen, it's really difficult. Okay, so let's imagine that they're the exact same size. And then you move one. So you take this one away from where it currently is, and you move it so it's sitting up here. Now, it's not actually the same length. Imagine I drew them and they were the same length. But a child who doesn't understand conservation of length might say, oh, hang on, this one looks bigger because it comes further up on the table that you've put it on. Whereas a kid that understands conservation of length realises, yeah, but it starts higher up, but it also finishes higher up. You can also have conservation of number. So here's a good example. I'll get rid of these ones. This is another pretty cool experiment that Piaget did. What he did was he just got a whole bunch of coins and he laid them out in a line. So coin 1, coin 2, coin 3, coin 4, coin 5, and then he laid out another line. And he said to kids, okay, which one of these has more coins? Now, all kids pretty much go, okay, yeah, they've got the same amount of coins, okay? But what he found was that kids that were in the pre-operational stage, so that age 2 to 7, let's say maybe a 5-year-old kid, what they were actually doing was sort of going, okay, the line of coins starts here and the line of coins starts here. The lines are the same length, so therefore there's the same number of coins. What he then did was he moved a couple of the coins and he spread them out so that the line was physically longer. And he said to kids, okay, which line has more coins? Now, as you can see, they've both got 5 coins, right? But kids in the pre-operational stage, say your 5-year-old, see that this line's physically longer. They think there's more coins there. They don't actually bother to count. They just go, oh, that one's longer. More coins. I want this line of coins. I want this line. Whereas a kid in the concrete operational stage, between about the ages of 7 and 12, they can understand, well, hang on, there's still 5 here and there's still 5 here. You've just spread these ones out, buddy. They're not fooled at all. They're like, well, duh, there's the same number in each line, mate. Yeah, because kids in that age generally have a bit of attitude. So that's called conservation of number. And there's lots of stuff about different conservation tasks on page 208 of your textbook. So what you should do is, first of all, have a read through that. Once you've had a read through that, head back to our awesome Year 11 Psychology Moodle page, scroll on down, Piaget videos, to this one here, Piagetian, I'm not exactly sure how you say that since it's a made-up word referring to Piaget, conservation tasks. And these are funny because the kids can't do them.